This is going to be chapter 3 of kinematic for AS level syllabus for 2019 to 2021. So before I teach chapter 3, there's some things you should know already during your GCSE. So you should know the difference between speed and velocity. You should know the difference between distance and displacement, and you should know the definition of all these words I mentioned here. You should also know about the displacement time graphs. So the y-axis represents displacement and the time represents the x-axis. So displacement, y-axis, time, x-axis. So this is going to be what it looks like, and you should be familiar with this. Now in AS physics we should what do you call it, we're now familiar with the velocity time graphs, which is mostly common during the exam, you could say, because the velocity time graphs give us the idea of acceleration. Now if you're not familiar with the velocity time graph, you can see here now the gradient of the slope represents acceleration, and the y-axis represents velocity, the x-axis represents time. So this is what it looks like when it's going to accelerate, but when it decelerates or slow down, the slope is going to go down. Yeah. Also, the acceleration is not going to change if the speed is not going to change. So if the speed is moving steadily, like moving but not speeding up, then you're going to have a constant acceleration that doesn't move. But when the car is not moving, then that means the car is stationary at that point. That means there is no acceleration. So the graph is going to look like this. So you should be able to familiarize with this graph or the shape. Next thing you should be familiar with is the Suvat equation. Now, in the physics exam, we won't be given a formula sheet with this, but you should be able to memorize these equations by heart. Yeah. S represents displacement, not speed. V represents final velocity. U represents initial velocity. And you should memorize the units as well. Well, we're going to be looking at these equations in practice later. So there's something I want to explain that is not in the book, but it's something you should know. Now, you are already familiar with the equation F equals to ma, which is force equals to mass times acceleration, and weight equals to mass times gravity. During GCSE, some people, well, less people actually, realize that these two equations are not the same. Actually, they're not the same. We use force, F equals to ma, for sometime in a horizontal component, sometime in diagonal component. But when we use weight, that's going to be weight equals to mass times gravity. We use a vertical component. So what's the difference actually? Because gravity has a constant of 9.81, approximately 9.81 meter per second square, because gravity is going to be pulling downwards, not sideways. So just keep in mind this law I wrote. use force in a horizontal component and use weight in a vertical component. If it's in neither component, then turn it into one of the component. Now, the last part is if it's neither component, then that will be taught later in chapter 4, resolving forces. But we move on to that later. Now, I just want to explain about the horizontal and vertical component. You should be able to understand differences and where it is in different situations. So now it's easy to know. Horizontal component is parallel to the slope or ground, while the vertical component is perpendicular or 90 degrees of the horizontal component of or the slope. So you can see here that the blue ball here, I'm trying to make a straight line here, so I hope you don't mind. Let's say this straight line. The vertical component, the horizontal component, it's going to be in here, sideways, and it's going to be parallel to the ground. You should know or be familiar with the word parallel, and is also perpendicular to the vertical component is perpendicular to the horizontal, and that's going to be a strict rule. So if you look at diagram number 2 here, if the slope is lifted up slightly on the right side by, let's say, an angle of 30 degrees, then the horizontal is going to be still parallel to the slope. So it's going to look like this. And this is the horizontal component. So the vertical component is going to be here. If you are still confused what horizontal component and vertical component is, it's basically a description of which one is horizontal, which one is vertical. So which one is horizontal, which one is vertical. So strictly, if I say where is this ball vertical motion, it's going to be here, not here. It's going to be here. Sorry, that's the horizontal. It's going to be here. That's the vertical motion. Horizontal component and vertical component will be taught later in chapter 4, but by now you should know that the vertical is just in this area, the red dot line, and the horizontal component is going to be in sideways area. So that's what you should know. Now, some student might be confused of this idea. Let's say that the body is going to be moving, right? So some question might mention like the velocity of the ball is going to be moving -5 meters per second. But what does that mean? Well, it means that the body, or let's say the ball, is going to be moving the opposite direction from the starting point. So this is going to be -5 meters per second. Okay, but why? Okay, so the confusing part is which one is positive and which one is negative. So the negative the positive is going to be the first traveling from the starting position. I put red arrows to represent which one is the starting represent. So the yellow dot here, it's going to be, let's say it's moving to the right first, and so that means that going to the right, that's going to be positive. Okay,